Welcome back, everybody. Welcome back to the channel. So, today we're going to be talking about what to expect from this YouTube series. So, we've kind of been talking a lot about various different things with the programming language. And I just think that now that we're kind of at I would say, a landmark point where we finished the beginning part of the compiler, we've also gone over various different things to set up the compiler. And we actually still do have one more setup video that's going to be on Monday, but I thought it would be a good idea to kind of take a break and kind of talk about what to expect from this YouTube series. Because, like I mentioned before, I'm pretty sure some of you guys are really curious and don't really want to have to wait until the very end to realize that, oh, I wasn't going to learn this thing that I was looking to learn. So, in the spirit of full transparency, I will first preface this video with saying I am not a professional compiler developer. I'm a Android developer. That's my main profession. So the things that and I think I said this before, but the things that you're going to see in this compiler, they're not going to be perfect. There's going to be issues. There might still be bugs, but I am doing my best, and I hope that you guys learn a ton from this and it speeds up your learning curve, whether you're trying to build a programming language or whatever your goals are. So let's just kind of see what are we going to learn from this tutorial series. So obviously there's going to be two main things we're going to learn. We're going to learn, and by the way, I could not list everything that we are going to learn from this tutorial series. This video will be way too long. I'm just putting the highlights, so don't worry if you didn't see something. That doesn't mean we're not going to learn it. That just means that I couldn't fit it in the video. So as you can see, we're going to be learning how to build a compiler and how to build a runtime system. So let's talk about the compiler. First, okay, well, I guess that's obvious. We're going to learn how to write a compiler. After that, we're going to learn how to compile expressions. So all of those various different things that we were doing, like new expressions, lambda expressions, so on and so forth, math expressions, we're going to learn how to compile and process all of that information on the backend side of our compiler. We're also going to learn how to handle and manage classes, fields, and methods. This one is a very big challenge for me, and I had lots of issues with doing this, but after developing this language for roughly 5 to 6 years, I think I've kind of gotten it down pat at this point. We're also going to learn the rules of ordering. Now, this one is a very interesting one, especially when it comes to processing information. So, like, this basically encompasses pre and post compiling. Those two phases, and as I mentioned this before, and you're actually going to see it, I would say about 75 to 80% of your compiler should be finished by the time you're done post-processing all of your code, which seems weird because the point of pre and post-processing is not to really process any information or to generate any code. The purpose is to figure out what everything is and how everything connects together in the programming language. So all you're doing is you're building a bunch of dependency graphs and figuring out the types of everything. So essentially, your type system is the entire compiler. So with that, we are going to learn how to write a dynamically compiled static type system. So our programming language is going to be statically typed, but it's going to be dynamically compiled in the sense that it's not going to be a straight line. So when we're compiling things, and we'll see this later on, but there is a very specific order, and it has to be this order because I've tried hundreds of various different variations of this order, and this is the ordering that, at least for me, works the best, and it has been proven to work time and time again with tons of testing. So we're going to learn how to process fields, functions, and classes in an unordered fashion. So if you create a field of X and you assign it to Y, and Y is defined below X, well, then we'll have to process that in some kind of way. Or like if you try to assign a field, a function that is attached to a getter or setter that is connected to a field that hasn't been processed yet, like that crazy example that I mentioned a while ago, we're also going to learn interesting stuff like that. And that kind of goes into, resolving types when they aren't really known. We're also going to learn how to map and prevent circular dependencies. There's certain situations, I don't want to get into it too much, but there's certain situations in our compiler where we're going to have to make sure that the user doesn't break the compiler, because they can easily do that. There's tons of things, like for instance, I'll give you one example. If you have a variable called x and you assign x to y and then y to z, and then z is equal to x, well, because our type system is going to be dynamic, it's not going to process all of that information at once. It's going to try to figure out what variable is at a specific point, and if it just circles back around to x, well, eventually you're going to get a Stack Overflow exception in your compiler. So, there's tons of different situations that we're going to learn, but that's just kind of one of them. We're also going to learn various different object-oriented principle implementations. So we're going to learn about inheritance, how to actually implement inheritance in a compiler, method overloading, method overriding, class abstraction, and more. I don't have to list them all, but you guys kind of get the point. We're also going to learn how to solve common processing conundrums, such as like returning from a lock statement or returning inside of a try-catch. This all encompasses like what if you have a go-to statement and go-to statements are basically the Wild West when it comes to compilers, because you have absolutely no idea where they're jumping to. You know that, there's a label that they want to jump to and you can store that name, but you have no idea where. So trying to figure out if they jump to a very obscure point in the function and they're inside of a try catch and potentially also inside of a lock statement, that's going to get very tricky to figure out how to actually process that information. So we're going to learn all of that. We're also going to learn how to build and manage an entire exception system. I have recently upgraded my exception system to something that I'm really proud of, and it is a lot faster than what it was before. It's not perfect, it's still pretty slow, but for the most part, it's pretty good. I'm also going to learn how to do instruction generation. This one is a huge pain in the ass for me. I have had tons of issues with it. I have figured out the issues, but and that one's going to be pretty complicated. We're also going to learn about control flow validation and building a branch management system. So control flow validation would be something like if you have a function that returns an integer, let's say, and not all control paths return a value. So we're going to have some type of control flow validation. Now the validation is going to be very rudimentary. It's not going to be very complicated. I have a very easy system for that, so I don't think that one will be too bad. We're also going to learn how to build a branch management system, which is basically going to encompass us bouncing around all over the place. Because as we're compiling things, right, we're gonna have all different types of crap that we're gonna have to do. We're gonna have finally blocks that we need to, like if we have a return statement or something, we need to execute those finally blocks before we leave the function. We have try catch blocks, we have if statements, for loops, just endless amounts of data that we need to process, and uncontrollably just bouncing all over the place is very complicated to track. So that's going to be an interesting one. Next, and like I said, by the way, I mean, this isn't everything. We're going to learn a lot more with the compiler. So this isn't everything. Don't worry if you didn't see something, but those are the highlights. So after that, we're going to learn how to build our virtual machine. Now, I'm going to be honest. Once we get done with the compiler, our language is basically done. Virtual machines are very simple. Well, at least I think so. I've built my virtual machine probably 60 times over from scratch, so it's pretty easy for me at this point. But in terms of the code base and how much code it's going to require for our virtual machine, it's minimal. Like we're not going to have that many files. You'll see it's not that bad. So we're going to learn how to build and process an executable file. That's going to be one of the first things that we're going to have to do, and that one is actually pretty complicated because we basically have to break out our instructions and we have to put data tables in there, symbol tables, and we also have to figure out how to link everything together, right? Because you could have like some data in there that's linking to another piece of data, but we haven't processed that information yet in the executable. So this isn't going to be like a Windows executable. This is going to be a executable that we're going to make up. It's arbitrary, but even still, it's pretty complicated. So we also are going to learn how to build a fully functional multi-threading platform. So basically that's going to encompass us being able to create threads, manage threads, and control them. Because of course we're going to have a garbage collector for our virtual machine. So we need a thread management system anyway to be able to, like, for instance, if we have to do a system-wide shutdown and basically like stop the entire programming language to collect a bunch of data because there's no memory, then we need our thread management system to do that. Also, fun fact, with this thread management system, when I first started, and it's still like this today, because I've been doing Android for so long, I actually took the multi-threading platform directly from the Dalvik virtual machine, which is the virtual machine that is run on Android. So that's going to be kind of cool. We'll kind of see. Now, obviously, it's been several years, so it's changed since then quite significantly, but it's deeply rooted in how the Dalvik virtual machine ran and managed threads. So I think that's pretty cool. We'll see that later. We'll also learn how to build, like I said, a efficient garbage collector. So with our garbage collector, we're going to learn the mark and sweep algorithm. That is the one that I picked. There's multiple algorithms that you can choose for garbage collection. I just picked that one because it made the most sense to me. So we'll just learn that. Our garbage collector also is going to be what's called a concurrent GC, or a concurrent garbage collector. What that means is it'll basically run in parallel with our programming language. There are other ways you can build garbage collectors, but in my opinion, I like this one the best because it basically allows you to run your systems harmoniously together. It's kind of like a contract, the way that I have it set up, where each thread agrees to allocate data in a specific manner, and the garbage collector then handles and manages that information. So each thread is basically going to just say, hey, garbage collector, I would like to create this object. The garbage collector says, okay, it creates that object for that thread, and it passes the reference to that thread, and then the garbage collector holds on to it. And from that point, it's basically hands off. The thread doesn't have to care about when it releases that object or what happens to that object. Once it has no more references, the garbage collector just magically destroys it. We're also going to have a DTAS system, or dynamic threshold adjustment system. That's just a fancy word. I made that up, by the way. Like that's not a thing, but it's basically just a system for dynamically managing the memory in our garbage collector, because as we're collecting things in our language, it's not always going to be so cut and dry. And this is one of those things that make it a lot more efficient. It's never going to be like, okay, my garbage collector has, like, I think the default value is 64 megs. So we start out with 64 megs allocated to the GC, and that's your limit. And the threshold is usually a magnitude lower than that. So let's say maybe the threshold is like 10 megs or something. So when you're running your programming language, just having a fixed threshold to say, all right, it's time to do the collection now is a bad idea, because what if you're allocating thousands of objects constantly? Then that means that once you allocate one object over that threshold, the garbage collector is going to be running constantly forever because you're over the threshold. So I created this DTAS system to basically alleviate that. And as we allocate more memory, the garbage collector will dynamically increase the threshold. So it's not bogging down the entire system by doing all these collections. We're also going to learn how to manage and handle memory errors. Of course, with the GC, you're going to have out of memory errors. We're also going to learn how to do system-wide collections. So this is going to be an homage to the Android system. Basically, I have what's called a suspension system, which basically suspends every single thread until they can be awoken again. So basically, every thread that's running is going to have a signal that they listen for, and it can be several values. You can kill a thread, you can put a thread to sleep. I think another one is you can throw an exception or something like that. So there's multiple different things, but yeah, so there's that. We're also going to learn how to build a JIT. This just-in-time compiler, I mentioned it before. It's going to be basically the last thing that we're going to learn how to build, because that takes a lot of time. Now, I plan to support 64-bit Windows and Linux, and possibly 32-bit. I'm not exactly sure if I'll be able to do it in time, because it's a crap ton of work, and I don't want to kill myself trying to get all of this work done. So I'm still working on the language. and I haven't even started on the JIT because obviously it's broken now because I've rewrote the entire language over again. So we're going to learn that. We're also going to learn how to build a GUI interface. So that's for like GUI applications. So if you want to build like a game or something, then we'll learn how to do that. That's going to be for Windows only. I'm not going to do it for Linux because apparently Linux does it differently. Like you have to, it's like a server connection or so. I don't know. I have no idea. But all I know is that doing GUI applications on Linux is a bit more complicated. So we'll just stick to Windows. We're also going to learn how to build an interpreter. So this is kind of goes hand in hand with just the virtual machine itself, because of course we're going to have a interpreted language. Like as our compiler is building all this code, it's going to be building it in an arbitrary programming language that we built ourselves. And it's going to reference a bunch of machine instructions that aren't real machine instructions, but it's the instructions for the runtime system or for the virtual machine. We're also going to learn how to build a high to low level interface. I call it a pipe interface. Basically, the way it works is this interface is going to be how we're going to do things like reading and writing to files, doing OS commands, interfacing with the computer, like accessing data, reading, writing files, so on and so forth. So the way it's going to work, and it's kind of interesting, you basically can imagine it like a pipe, and you put a bunch of information in there, and then you close the lid, and then you hit a button, and then it flushes that straight to the virtual machine. The virtual machine will then take that information and do something with it and potentially return information back. So, like if we wanted to access a file, or if we wanted to create a directory or something like a new folder, then of course we'll get that information back. So let's talk about what we won't learn. So even though there's going to be a ton of stuff packed into this YouTube series, there are some things we're not going to learn. And those will consist of complex compiler design concepts, such as advanced code optimization, loop unrolling, etc. Um, I just want to say that this is the second time I've ever written a compiler ever. So I don't have much experience in compiler design. When it comes to building a virtual machine, though, I've been doing that for years because they're easy to build. And I've built probably 60 of them, like I said already. So we're going to learn, in my opinion, I think we're actually going to learn more on that side than we are on the compiler side. But there's plenty of stuff to learn on both sides. So we should be fine. But we're also not going to learn advanced code inspection. So that's basically like data flow analysis. Basically, what that is like in C++ plus plus and other languages, they have a way in their compiler to do advanced code inspection to basically look at if statements, look at while loops, and like just various different control flow mechanisms, and reading and interpreting the code real time as it's compiling to figure out if maybe the user, like maybe it'll give you a hint, or I don't know, maybe you'll get better errors. Because even though I said before that we're going to have a control flow system for our compiler, it's not a perfect system. It's very stupid. It's not smart. So for instance, if you have an if statement, like if true, and you return a value, our compiler is still going to think that not all control paths return a value, because it doesn't know that the if statement will always evaluate to true, if that makes any sense. So that's one thing. We're also not going to do function inlining. I have no idea how to do that, honestly, and especially considering the way my programming language works, I don't know how to do that. So we're not going to do that. We're also not going to learn a JNI like interface. Like, and that's basically direct interfacing with C++, so like processing DLL files. That is something I want to add. So this is one of those things where I will try my best to get it in to see if we can put that in the YouTube series, but there's no promises. So I'm not exactly sure about that one. Most likely it probably won't be in, and possibly more. Like these are just a few things that I noticed and I kind of thought of that we're not going to learn in the YouTube series, but yeah, so that's going to be it for today, guys. Thanks for sticking by. Thanks for staying with me all this time. I know it's been a long ride, and I just want to take the time to say I want to thank you guys for being so awesome and coming back to my YouTube channel, because I know that I like dropped off a while ago for like a couple years and didn't really come back and didn't really upload videos. So I just want to say I really appreciate it. Special shout out to Sim Gunther. You're awesome. Thanks for sticking by, and keep the comments and suggestions coming. One thing that I will say before I head out, currently, as I mentioned before, I was able to build my first Hello World program. And basically, after that point, the development with the language has piked pretty substantially. And I know it's only been like a day or whatever, but that's usually how it works. Once you're able to print Hello World, you can pretty much do almost everything in the language. So currently I'm building the standard library and I want you guys to put some suggestions in the comment section below as to what you want to see me build in that standard library, because at that point sky's the limit. Like, I can do whatever because obviously I built the language. So I already got some ideas on some cool stuff that I want to add in, and it's going to be everything. Like, I'm going to have to build a networking library. I'm gonna have to build a multi-threading library at the high level, amongst other things as well. So, like I said, give me some suggestions if you guys want to see anything cool. And yeah, so that's gonna be it for today, guys. As usual, if you guys would love to help support the channel, definitely head over to my GitHub repository at androidfcd/sharp. And when you do, definitely watch, start, and fork this repository. That's going to give this programming language a lot more visibility and let other developers know this language exists. Also, if you guys are curious about what I've been up to on a daily basis, you can head over to the remastered branch. You can check out the commits. I write some pretty wordy commits, so you can kind of get a gist of what I've been up to without really having to look too much in the code. Also, if you're curious about learning maybe what are some of the things that I'm looking to add in the future with this language as it develops, or maybe stuff that I worked on in the past, you can head over to the docs folder, and there's going to be two main files. There's going to be the changeless file that's rarely updated. This one basically is just any past updates that I did to the language. And the roadmap file is pretty much not only that, but also stuff that I'm looking to add in the future. So hope everybody enjoyed the video. As usual, if you guys are new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.